material. We're going to mostly finish up the material for our first exam. So we're going to work on predicates and quantifiers for mostly today. Next Monday, whatever we don't finish, we'll spend about a half hour finishing up. We might have to do like some of the multiple quantifiers, and we might have to do a few of the Venn diagram stuff at the end, which won't be too difficult. And then what I'm anticipating is about half the class we'll spend just talking about what's going to be on the examination. Okay, so generally what I do to review for an examination, I make up the exam ahead of time, and I just let you guys know like the types of questions that'll be on there. Okay, so it shouldn't be a surprise as to what's on there. Sometimes I just cut and paste stuff from the actual practice exam. Sometimes I take problems off the assignments. Okay, but basically the assignments are a good gauge as to what to expect to see on the exam.
Can you give us the answers on Monday?
For the practice exam?
Just say for the exam in general.
Oh, to the examination?
Yeah.
I could, but then I'd have to make up another exam. so no, I guess I won't do that. Okay.
I didn't look on Blackboard. Is there still going to be homework due on Wednesday?
Yeah, what I'll do is I'll make the assignment number 3. I guess I'll just make that due either, I'll probably make it due the day after the examination, the class after that. Because that way you guys don't have to do the homework and study for the exam. That would be kind of cool for me to do. Although it's a good way to study for the exam. Yeah, so. Okay. All right, guys, any other questions I can answer? Sir?
Can I have a packet?
You may, absolutely. Yeah, that would be helpful. That's a good question. So, and then actually, so do me a favor. Can you pass that behind you? And then there's 2 in there. Can you pass it behind you to the 2 gentlemen in the back? Well, 2 gentlemen. Oh, sorry, 3 gentlemen, but 1 half is not a gentleman. Sorry, Don. That's kind of fun. All right. So let's go through and start talking about some of the definitions of what a predicate and quantifier is. And when we talk about a predicate, guys, a predicate is essentially almost like a function that's either true or false when you insert specific values. Okay? So when I talk about the definition of a predicate is almost like a function, except the output is either true or false. Okay, so whenever you guys are doing this, you don't necessarily get a value out. You don't get a number out of it, or you don't get like anything like that. You just get a true or false. Okay, so the only outputs for a predicate are true and false. Okay, so it's sort of like a function in some respects, but in some respects it's not. Okay, and you guys know that there's only a certain number of values that you can plug into a function. Same thing with the truth set. Okay, as a predicate, that is the domain. Okay, so there's going to be sometimes you can't put elements into it. Okay, all right, and then the truth set of a predicate are all the values that make a predicate valid. So I just want to go through and show you a very basic illustration of what a predicate is, okay? And then we're going to start talking about quantifiers. But basically, this whole packet and the rest of the class before the first exam is going to be on what predicates are, okay? So I'm going to have a predicate, okay? And the predicate P of x is going to be x greater than 1 over x, or greater than or equal to, okay? First thing I want to do, I want to write P of a half, P of 1, and determine their truth value. Okay? So if I wanted to write P of 1 or P of 0.5, okay, P of 0.5 is going to be 0.5 greater than or equal to 1 over 0.5. Okay? So that's what our predicate would look like when we substitute the value in. Okay? So like I said, it's just like a function, except it has a symbol on the other side. Usually functions don't have this. Okay? Now, guys, what's the output for this truth, or what is the truth value for this predicate when substituted? It's false, right, guys? Because we know this just works out to be 1/2 is bigger than 2, and that's not true. Okay, so the output is false. Okay, so that would be the truth value for this. Okay, so guys, predicates are very easy to work with, right, guys? They're not difficult. Okay, you stick a number in, it's either true or false. So you got a 50-50 shot of getting it right. You also have a 50-50 shot of getting it wrong. P of 1 is just 1 bigger than or equal to 1 over 1. And guys, what's the truth value of that statement?
True.
To go be true, right? 1 is bigger than or equal to 1. Okay? So we would say this is true. Okay? All right. We wish the entire exam was made up of this question, right, guys? It'd be really easy. Okay? All right. Let's talk about truth sets as well. Okay, we talked about truth values, now our truth sets. So, let's let the domain of the value x be x is a negative real number. Okay, so whenever you guys see r in this class, that's just a real number. Okay, and whenever you see the superscript minus, that's just negative real. So when you guys see this, that's negative real. If I can spell. So it's negative real numbers. Okay. And in the next one, if you see r super plus, that means positive reals. Okay. I want to find the truth set of p of x. Okay. So basically, what I'm trying to figure out is what numbers make that true. Okay. So when is x bigger than or equal to 1 over x true? So that's what we're basically asking. And that's not necessarily an easy question, right guys? Because we know that this is basically going to be a rational inequality. Okay, those aren't too nice, okay? But this is one we can probably just bully and we can try to figure it out, okay? Now remember, we're only dealing with negative real numbers. So what we might want to do is let's just try like some values and see if it's true or not. Okay, so let's say for some reason I tried p of negative 2. Okay, so I'm just going to basically do trial and error and see what works. Okay, p at negative 2 is bigger than or equal to negative 1/2. Okay, guys, what do we think about that statement?
False.
True or false?
False.
That's false, right, guys? So we know that 2 is not part of the truth set. So what we might want to do is just make a number line. Okay, and all we care about are numbers that are less than 0. And basically, guys, I don't think anything less than negative 2 is going to work, okay? Because think about it, guys, if you plug in negative 3, negative 4, negative 5, negative 6, doesn't that look like it's not going to work, okay? Let's try p at negative 1. Okay. What do you guys think about p at negative 1? Is negative 1 bigger than or equal to negative 1 over 1?
That's true.
That's true, right? So I'm thinking that that's going to be at least part of the truth set. Okay, so maybe what we can do is maybe try a number between negative 1 and 2, and then try a number between 0 and 1. Okay, so let's try p at negative 1.5. Okay, so like I said, we're just bullying this to see if it works. 1.5 bigger than or equal to negative 1 over 1.5.
So 1.5 is 3/2, right? So
That's correct.
So 2/3.
So
No, false.
That would be false, okay? And you guys could just use your calculator, right? You can see that very easily, okay? So this one doesn't work. So this doesn't work. But I believe 1/2 is going to work if I try to number in between there. Okay, so let's try p at 0.5 negative. And that would be equal to negative 0.5 bigger than or equal to negative 1 over negative 0.5, or sorry, not double negative, double. Okay. And guys, what do we think about that? Is negative 0.5 greater than negative 2? Yeah, absolutely.
True,
Okay. So to me, it looks like that the truth set of this predicate is probably going to be all the numbers between negative 1 and 0. Okay. Guys, does it include negative 1?
Yes.
Yes. Okay, so we would put a bracket at negative 1. Does it include 0?
Mm-hmm.
No.
No, 0, no.
How come it doesn't, guys?
Because infinity.
Because it's not in the domain of the function, right, guys? Or, I'm sorry, not the function, predicate. Sorry. All I said all my life is functions, functions, functions. This is the one time I get to say predicate. Okay? So, wouldn't the truth set be negative 1, I'm sorry, negative 1 comma 0, negative 1 inclusive, 0 bracket, okay? So when we talk about the truth set of a predicate, we're talking about all the values that make it true, okay? And I know there's a better way to do this, okay? Most of you guys, like some of you guys, if you know the algebraic method, you'd multiply both sides by x, you'd say x squared minus 1 equals 0, you'd find the critical values and then do a number line that way, okay? That's another way to do it, okay? If you don't know that method, just beat it up. Just keep doing trial and error, okay? That's a little bit easier, right? And it's not like I'm asking you guys to do a tough calculator. Okay. Now we're saying, for the last part, let the domain of x be all real numbers. Now we're going to find the truth set of p of x. Okay. So we already know what's happening on the left side of the graph, right guys? So we don't want to redo the whole problem. Now we're just trying to figure out what happens on the right side of the graph, okay? Now think about this, guys. What do we already know about P of 1? Is it true or false?
True.
It's true, right? We already know P of 1 is true. So we know that's going to be, in fact, that's probably going to be the other critical value per se. Don't we already know that 0.5 is false? So wouldn't it assume that anything between 0 and 1 is false as well? Okay? Like if I plugged in a 0.2 or 0.7 or something like that, I know that would be false. So I think the best thing to do is maybe figure out what happens for P of 2. And I think it's going to be very obvious that for P of 2, where 2 is bigger than or equal to 1/2, I don't think anyone in this room doubts it, okay? And if you do, I'm going to beat up your Calc 1 teacher, okay? Well, maybe not, depending on who they are. So if they're bigger than me, no. So if they're smaller than me, yes. All right. But guys, it looks like that 2 is going to work. So doesn't it look like that it's going to be everything to the right of 1, okay? And it's inclusive of 1, right guys? Okay. So if I was to ask you for the truth set for the last part,
1 to infinity.
okay. So it will be bracket 1 to infinity is part of the truth set for this problem, right? What's the other part? -1 to 0, right?
Oh,
Because isn't our domain all real numbers this time? Last time it was just negatives. So we're not just specifying ourselves to positive reals. This time it's negative and positive. So the way we would denote that would be bracket -1, 0, union -1 to infinity. Right, guys? Okay. So I'm just trying to give you guys a problem where, like, you see the truth set, and you guys can identify the difference between truth value and truth set, okay? Truth value is either true or false, okay? A Boolean sort of statement, okay? Truth set could be an infinite range of values, okay? So guys, do we understand the difference between it? It's not meant to be different.
I got a question.
Sure.
Shouldn't that be -1? Shouldn't that be like one of this, the bracket? Yeah.
Yeah, it is a bracket. Either your vision's bad or my handwriting's bad, or maybe it's both.
Both could
Yeah.
be.
So I'll blame myself on that. Okay. All right. Other questions, guys, I can answer about this. Okay. So let's start talking about some of these quantifiers. Okay. And quantifiers are going to be the big part of what we talk about in this class from now until the end of the course. We use quantifiers. Okay. Right now, guys, I'm just building up your syntax, okay? Just like if you guys were a computer programmer, right? You have some specific syntax that makes the program run. If you don't use the specific syntax, the program doesn't run. Okay. Guys, if you ever see this upside down A, that is the universal statement, okay? Upside down A means for all, for every instance, for each and everything, okay? Any element in the set, okay? That's the ways that we would think about that. Okay? So, if you have a universal statement, okay, and this right here, okay, this is alliterated all x in domain D, predicate q of x. Okay, so this is going to be a structure or a format that we're going to be using quite often today and also quite often in the rest of the course. Okay? This is true if every element in the domain satisfies the predicate. Okay, so that's the only way a for all could be true. Okay, all right. It's false if any one of them's false. That means that the original statement's false. Okay. To verify one of these, so basically counterexample would disprove it, and then you would have to go through something called exhaustion to prove one of these. Okay, so we're going to see plenty of examples of this, by the way, guys. So I know that's a lot to digest, but quite honestly, it's not that difficult. Okay. Because if you think about it, okay, like let's say I said this statement, okay, every student in this class is named Kevin. That's a false statement, right? Because all I would have to do is just point at Paul, and Paul's name is not Kevin, okay? That's a counterexample, okay? But what if I said the statement that every student in this class has taken Algebra 1, okay? Has anyone in this class never taken Algebra 1 or an equivalent of Algebra 1? Don't raise your hand. So let me rephrase that, okay? You might not have passed it, but you took it, okay? Sorry about that, Donnie, I had to get it when I can, okay? But guys, that's a true statement because I've exhausted every possibility. I went around, I looked at you guys, and there was not one instance that said it was true. Okay, so, guys, does that make sense? That's all we're trying to show with this. Okay? The other quantifier is the existential quantifier. Okay? Existential, look at the word existential. It has the word exist. There exists at least one. There are some. There are a few. Some of these, okay? Those are all different ways to sort of alliterate this guy right here, okay? This is the statement. There exists an element x in domain D such that predicate q of x is true, okay? All right, it's defined to be true if there's at least one element in the set that makes it true, okay? So all you have to do is just find one person named Kevin, okay? There's a person in this class named Kevin, right? So if I said, there are some students in this class named Kevin, that would be a true statement, right guys? Okay, because there's at least one, okay?
What happened, like if you said there is every student in this class is named Kevin, everything is false, but there is one student that is Kevin.
Nope, that's not true, not for all.
No,
Okay?
but say for example, if you say that there's every student in the class is named Kevin, right?
That's a universal statement.
Yeah, but for example, in that way, you know that not all students are named Kevin, but only one, at least one is Kevin, then?
Still false.
Still false, okay.
Yes, sir. The only way this can be true is if everybody was named Kevin.
Right,
So that's a universal. Existential means you only need one. Okay? To prove an existential statement true, you just find an example, existence. Okay? To prove it false, you have to use exhaustion. You go through, you show everybody's not named Kevin, okay, which isn't true. Okay? So guys, that's all these are. Okay, we're going to be using these quite often in class. Let's just go through and take a look at how we're going to utilize it. Okay, it's actually very easy to do.
So it's kind of like the and the or statement. And universal is and.
Oh,
Everything
no,
is
well, we're going to see what happens when we put ands in there, okay? Those are going to be multiple quantifiers, okay? So, but for right now, we're just worried about singulars. Okay?
Gotcha.
All right. So, all I want to do is I just want to write these symbolically using the correct format, okay? So, the first phrase here, all cats are mammals. By the way, we don't care if it's true or not, okay? We're just going to write it, okay? Here's how I would... Sorry, I'm all choked up over this stuff. It's so exciting. Here's how I'm going to write this first sentence using the universal quantifier. I'm going to say, for all x in a specific domain, okay? Guys, what domain am I looking at for this problem? Not mammals, but cats, right? So for all x in the domain of cats, x is a mammal, okay? That's how we would write that sentence using the format, okay? So that's a universal quantifying format, okay? Does that make sense, guys? It's not difficult, okay? No differential equations, no integrals in there, nice and easy, okay? Every integer is a real number, or is a real numbers, apparently, because I'm no good at New English, all right? So every integer is a real number. Two ways we could write that, okay? We could say, for all x in integers, x is real. Or another way that we could write that is we could write it a little bit more compactly. We could say for all x in the set of integers. Okay? Does anyone know what the symbol is for integers? What letter represents integers? It's not I, that's irrational.
N?
Not N, that's natural. Good try. So now you have a 1 in 24 shot. You know it's not 2. And you know it's not R either. It's a 1 in 23 shot. Not D. Good try.
That's another one. It's a good one.
Z. Yeah. That makes perfect sense, right?
Oh, well, of course.
Yeah, of course. In German, which was actually where the term integer was sort of formulated, Zahlen is the German word for integer. So that's why they picked Z for that. Okay. So if you guys are ever on Jeopardy and you get that question,
It's actually a German term for count.
okay. Well, yeah, it's derived from the word. So but, okay, sorry, I didn't know I had any Germans in the class.
What a good count.
No, mine is German, so.
And I mean, that's what an integer is, right, guys? It's a counting number almost. It's almost like, except it's not negative, or it's negative or positive. And we can also say for all x and z, we could say x is in the real numbers, okay? Make sure you guys can do it both ways, okay? So if you guys see the letter z, from now on, make sure you guys know that that's an integer value. All right, there are students that study math, okay? So that's not a universal statement, right? That's an existential statement. So the way I would write this, okay, is I would say there exists x in students such that x studies math. So take a look at the form of that, okay? It's almost the same form as the universal quantifier, right? Except we just switch the symbol. Instead of for all, we say there exists. And instead of the comma, we use the such that. Okay, so those are really the only differences. We still have a predicate. X is a mammal, which could be true or false depending upon what we throw in there. X studies math, what could be true or false depending upon what we throw in there for X. Okay? There's at least one bird that cannot fly. Okay? And again, we don't care if it's true or not. Does somebody want to take a guess, or does somebody think they might know how to write that? Art?
There exists at least one bird that cannot fly. That's
Okay.
such that cannot fly.
Okay, so if I was to write that
Such
symbolically, the first thing I
that
would write is
E-
the backwards E. Okay.
Okay. Then X.
Mhm.
Then that E thing.
As an element, good.
Then bird.
Okay, so X an element of birds.
Such that
Mhm.
one bird. So one bird or X bird.
X
Bird.
cannot fly.
X cannot fly. Okay.
Yeah. Okay. And again, I mean, we know that's a true statement, right, guys? We can certainly find one bird that can't fly.
When we're answering the problems, should we use the such that symbol, or do you want us to literally write?
Oh yeah, you can use the vertical line for that if you want to. Okay. I'm just going about the way the textbook does it because I don't want to do two different manners of it. But I understand that. Do you guys know that the vertical line means such that? Fine. Okay. Guys, is this easy enough? Any questions about that? Okay, really easy stuff. Okay, Bart, go ahead.
So X is like you do in math, the domain, right?
X is a specific instance.
Specific instance.
Right. You're defining X to be one element in a whole domain.
Oh, the whole domain. Okay.
But X is one specific value in that domain.
Gotcha.
Other questions, guys? Okay. Let's take a bunch of statements, determine if they're true or false, and let's justify a response. Okay? So, let's say the domain D is equal to 2, 4, 5, 6, 7. I want to show that for all x in D, 2x is less than or equal to 15. Okay? How do we verify that, or how do we disprove that?
You have to do the math on everywhere.
Just stick them in, right? So let's just evaluate. Okay? So I would do 2 times 2 less than or equal to 15. Okay, that's true. I would do 2 times 4 less than or equal to 15. That's true. 2 times 5 less than or equal to 15. That's true. 2 times 6 less than or equal to 15. That's true. 2 times 7 less than or equal to 15. That's true. Okay? And remember, this is a universal statement, so I have to show that all of them are true. Okay? Guys, what was that process called when we showed every instance satisfies the predicate? It starts with an E. Exhaustion, right? And now you know why it's called exhaustion, because you write it out and your hand's exhausted from it. Ha ha ha. That's the best math joke I have. Sorry. Alright. So, this is valid by exhaustion. So, if I was to ask you guys this on a test or a homework or something like that, yes, you'd have to show them all. Okay? The good news is I'm not going to give you guys like 500 or something like that. I'll just literally give you like 5 or 6, okay? And if anybody dies from it, let me know. I'll give you an A in the course. All right. The next one. Show that for all x in D, x cubed is bigger than 9. Okay? Now, what do we think about that statement, guys? Is that true or false?
False.
That's false. How come, guys?
4 cube is 2 cube.
2 cubed is 8, right?
Yep.
Obviously. So let's do this. Okay. We would say 2 to the third is not bigger than or equal to 9. Okay. Clearly, everybody in here knows this. Okay. Even Donnie that didn't pass algebra 1 apparently. All right. So, guys, that statement is now false. And guys, how do we describe, or why is it false? Starts with a C. What explanation?
Contradiction.
Not contradiction, close. Rhymes with counter example. Counter example, that's it. You just need the right problem, right, guys? So this is false. This is B by counter example. Okay? So we're just getting our reasons as to why they're valid or why they're invalid. Okay? Does that make sense, guys? That's how you either prove or disprove a universal statement. Let's take a look at some existential statements. Okay? So now we have F, which looks strangely similar to D, but so I decided to give it a new definition. So we have F equal to 2, 4, 5, 6, 7. Show that there exists an X in F, that X equals 1 over X cubed. Okay? Now, is that statement true or false, guys? That's false, right?
Okay.
Because no matter what number you plug in, it's not going to work, right? In fact, the only numbers that work are 1 and -1 for this. Okay? So, how do we show that there is no number in this domain that satisfies it?
So to do the exhaustion, how
Just write them out, right, guys? You just write them all out and you go through and you exhaust all the possibilities. Okay? So, I would say 2 is not equal to 1 over 2 cubed. I would say 4 is not equal to 1 over 4 cubed. I would say 5 is not equal to 1 over 5 cubed. 6 is not equal to 1 over 6 cubed. And I think there was a 7 in there, right, guys? Yep. 7 not equal to 1 over 7 cubed. Okay. We have exhausted every possibility and we did not find a single instance that satisfies it. So we would say that this statement is false, and we say it's false by exhaustion.
So we can't use the word invalid by exhaustion?
Oh, sure, you can say invalid, sure.
Okay.
It's the same thing to me. All right, easy enough, right, guys? For the last one, I want to show that there exists an x in I plus such that x is less than or equal to 7. Right?
That's
So
true.
I think the first thing we want to think of is, what does I plus mean to us? Like, what set is that?
That's not integer.
Not integers. Not imaginary, good try. Actually, imaginary is C for complex. That's actually pretty good. Not a bad guess.
Irrational?
Irrational, very nice. Okay? So, whenever you see I plus, that's positive irrationals, right, guys? So, I plus, or it's just a really bad blood type. So, positive irrationals. And we know what an irrational number is, right, guys? It's a number that never terminates, never repeats.
Pi.
Okay? Like
E.
pi, right?
E.
E, okay. Square root of 2, okay? In fact, aren't those all numbers that are less than or equal to 7, right?
Yep.
So there's actually a multitude of numbers we could pick, okay? So we could go ahead and say something like pi is less than or equal to 7. Well, there we go. We have just found a positive irrational number that is less than 7. So the statement is true because we found at least one. Now we started rattling off a few more. We said e, the natural exponential base. We said square root of 2. Okay, but this is valid by, okay? And if you can find at least one instance, it's not exhaustion, but it's another E word. What is it, guys? Existence, okay? So this is valid by existence. There exists at least one. Okay. So, now we know how to prove, now we know how to disprove these. Okay? The problem is, what happens when we start trying, bless you, what happens when we start defining domains that are infinite, okay? Bless you. Okay? That's actually going to be in the next part of the course where we start studying direct proof. Like for instance, I can tell you the sum of two even numbers or even integers is even. How would you prove that by exhaustion? You couldn't, right? Because there are an infinite number of even numbers, okay?
In this class, are there such things as like fallacies or something like that?
Sure, we could run into, and you would actually disprove that by contradiction, okay?
Okay, yeah, because this thing like how we would refer to those. So like, if we're gonna get there, then you don't need to say.
Yep, don't even sweat it for right now, okay? Worry about that in about 3 weeks. Okay, other questions, guys? All right, so the next thing I want to talk about is a universal conditional statement, okay? We know what conditional is, if then, okay? So if I study, then I will pass, okay? If I show up to work, or if I show up Monday, then I will get the job, okay? What I want to do is, I want to write one of these sorts of things, okay? So I want to write it in a sentence, and then I want to go the other way, and I want to write it symbolically. Okay, so let's just go ahead, try to decipher what this says, and then we're going to go ahead and write it symbolically. Okay, these aren't too difficult. Alright, so, our first one, we have all x and z, if x squared is even, then x is even. Okay? Does somebody want to try to tell me what that's actually saying to us? Like if you had to describe that to a 9th grader or a 10th grader or something like that.
For all integer x, x squared is even if x is even.
Okay, so for all integers, okay, and we're going to try not to use any variables whatsoever, because a variable is considered a syntactical or symbolic sort of item. Okay, we don't want to use any symbols. So for all integers, then what? If the integer is squared, right? So if the integer is squared, or if the integer squared is even, sorry. So if the integer squared is even, then what, guys?
The integer is even.
Then the integer is even. Good. Okay. So we just want to make sure that we replace x with what the actual name of it is. Okay. So for all integers, if the integer squared is even, then the integer is even as well. Or we could just say is even. Okay? So when I ask you guys to translate into a sentence, no variables, okay? All you guys do is you just literally use English words. Okay? So like I said, like just imagine like there's no variables or there's no syntax in the sentence whatsoever. Okay. The next example, okay? All y in n plus, if y over 2 is in z plus, then y must be even, okay? Well, part of it's already done, must be even. So, I guess my first question is n plus. What does n plus mean?
N is, what does n?
Natural numbers,
Natural number.
okay? So, n plus means positive natural numbers. Okay? So, what we would say is, for all positive natural numbers, then what? How do I write the rest of that? Anybody want to
If natural number divided by 2.
Okay, so if the natural number, I like it, divided by 2, or half the natural number,
is part of the integer, positive integer.
is an integer. Okay, we could just say is an integer.
Is an integer. Positive.
It's a positive integer. Thank you. Sorry, I forgot that there was a plus up there. Is a positive integer. Okay.
Then the natural number must be even.
Then the positive natural number,
Must
or we
be-
could just say the natural number, that's fine. Because we defined it to be all positive natural numbers, so we already know we're only dealing with those initially, okay? So, if the natural number divided by 2 is a positive integer, then the natural number must be even. Alright. Yeah, it's a pain in the butt, I know, to write these out. But the whole purpose is just to make sure that you guys can express what's being said, okay? And I think that's one of the things, like sometimes when you guys are reading like a mathematical book or something like that, math books are really dense, right? Like if you go to read a book like that's not math, It might take you guys like maybe 2 minutes to read a page. Sometimes when you're reading a math book or a science book, it might take you 10, 15 minutes just to read one page because it's really dense, right? And that's the sort of thing that we want to make sure of, is that when you're reading these dense sort of texts, that you can translate them.
Did you ever do a course on real analysis?
I took one.
That's all like this.
Oh yeah, real analysis is the devil. It really is. So it was probably the hardest undergrad course I took, other than operating systems. I'll tell you guys about that another time. Okay. Let's do the other way around, okay? Let's write the sentence in a formal universal conditional statement, okay? If n is even, then 3n is even, okay? So, first of all, we have to define the domain, okay? So, for all n, what domain could even numbers be in? It can't be rational, it can't be real numbers, it can't be irrational. Integers, right? Because it could be either a positive number, could be a negative number, could be 0. Those are all possible numbers that could be even. So for all n in, and if I want to write symbolically, by the way guys, what letter represented integers?
Z.
Z. And couldn't we do this?
Positive.
Z even.
Okay.
Okay. So for all n in Z even. Okay. So if you ever see that, guys, that means you're dealing with the even integers. Okay. Then couldn't we just write the rest of it? If n is in Z even, okay, then 3n is in Z. I think when we're done with this example, what I'm going to do is I'm going to write up all the possible symbols so that way you have them in one place, okay? Because we're throwing out a lot of stuff all at one time. So I'll write them all down for you guys so that way you just have like a library of those. Does that make sense to everybody, guys? Any questions? Not meant to be difficult. Okay. If n is odd, then n to the 4th is odd. So guys, we'd write it the exact same way, except now we would use odd. Okay, so for all n in Z odd, if n is in Z odd, then n to the 4th is in Z odd as well. Okay. Does this make sense, guys? Any questions about it? Not meant to be difficult, okay? It's one of those things where you just want to go back through a few times, make sure you're good with it. Okay. Let me just write up like a library of some of the symbols that we're going to be using so that way you guys have it all in one place, okay? And the different sets, okay? So, and in fact, let's just start at the top, the highest place as to where a set is, okay? And let's not go past like one-dimensional. Like for those of you guys that have suffered through linear algebra, you guys know that there's like 2 or 3-dimensional matrices. Like you guys have seen R3 that have taken linear algebra. You don't want to deal with that, but there is something like that, okay? It's a vector space, if you would. Okay. So at the very top of the one-dimensional number set are the complex numbers. So whenever you see C, that is the complex, okay? Which are basically imaginary numbers as well, okay? Complex has a real part and imaginary part too, okay? Whenever you guys see R, that's a real number. Whenever you see rational numbers, okay? Does anybody know what symbol is used for rational? And obviously it's not R, because that's already reserved for real.
A.
A is not a big guess. I'll give you a hint. It's not Z, it's not N, it's not R, it's not C. Q it is.
What, really?
Yeah. Did you just guess?
Yeah.
Nice. Do you have any reason as to why you guessed Q?
No, it's the next letter.
Next letter that came to mind. Nice. Really damn good guess. We're going to Vegas, man. Put it all in 32. All right. A rational number is the quotient of 2 integers. Quota. Okay? So Latin. Okay? So really good guess, man. Nice. Do that on the exam, you'll be great. Just guess that. Right. Next thing, rational numbers are irrational numbers. We already saw that. Okay. We already saw integers, Z. We haven't seen these today, but there is a set called the whole numbers. Okay. What letter would you guys suspect whole numbers to represent it by? W, and it actually is. Finally, one that makes some freaking sense. All right. And then the last set that we look at are the natural numbers.
Two questions I got.
Yeah.
Which one are the natural numbers?
Natural numbers are like your counting numbers. 1, 2, 3, 4, 5. Basically like the number of people in this room. Okay, that would be a natural number. Because if there's 0 people in the room, it doesn't make any sense.
Oh, so any number over 0?
Any whole number, any integer bigger than 0. I'll say that.
Natural.
And the whole numbers start at 0.
Okay.
That's the difference between a natural and a whole number. I don't know why they made that up, because couldn't you just say whole number minus 0? I guess that would make too much sense.
And what are...
You're using natural for the end, or is that what the flat is?
Oh, no. That would be natural positive numbers.
Wait, I thought you just said the natural numbers.
Correct. So you never really want to write that anyway, because they're implicitly. Okay. Yeah, it was a trick. Sorry. All right. Or you were going to say something?
And what are these things like set? Like, are they the precedents or something? What are
Oh, these are just the representations for sets.
Oh.
So when you see these letters, that's what they mean.
Okay.
So we don't have to write out integer or irrational all the time. Okay. By the way, and for those of you guys that have taken linear algebra, there is this thing called R2. Okay. And does anybody know, or can anybody tell me what R2 is? Yeah, super R, right? Yeah. No. R2 is actually a matrix. It's a 2x2 matrix. Okay. So, and we'll never use that in this class, by the way, but. For some reason, and I know some of you guys are in physics and some of you guys are in engineering courses, and sometimes they represent vectors using matrices, okay? I just wanted to make sure that if you saw this in another class, that you actually get something useful out of me for once, okay? All right, so, but in our class, these are the ones I'm going to restrict those to, okay? So does that help out a little bit? Go ahead.
So you put n plus on this.
I did, just to mess with you guys,
right.
Absolutely. Wasn't that just mean of me? You can write that on the teacher evaluation. Plays
Mean
Jedi
teacher.
mind tricks. Yep. All right. Other questions, guys? Okay. Now that we know how to write all of these different statements, let's now write the negations of those statements, okay? And later in the course, negations are going to be just as important, if not more important, than the regular statements, okay? So, these are going to be the forms that we need, okay? So, if I have a universal statement and I want to write the negation of that statement, what I do is I flip the quantifier. Instead of a comma, I use such that. And instead of q of x, I just say not q of x. Okay, so there's only 3 things that change. You flip the quantifier. Instead of a comma, it goes to such that. And then you would say not q of x. Okay. For all x in the existential statement, again, you flip the quantifier. You flip the such that to a comma, and then not q of x. Okay? So the negations for universal and existential are actually pretty logically almost the same thing. Okay? For a conditional statement, okay, now this is the one that's a little bit sketchy. So what you would do is you flip the quantifier. So there exists an x in domain D, the comma to a such that, but instead of a conditional statement, it becomes a conjunction. Okay? With p of x and not q of x, okay? So make sure like you guys memorize those, or I'm going to allow you guys to use a note card for the examination. So it might be helpful for you guys to write these on the note card, so that way you know what the forms are, okay? Eventually we're just going to do it so many times that we're going to memorize it anyway, but for now, maybe we don't have it memorized and we got other stuff going on, so it might be good to write on your note card, okay? Let's see some examples of this stuff, okay? So how do we write these things symbolically and all that good stuff? Okay, so I'm giving you 3 sentences. One's universal, one's existential, one's going to be conditional. We're going to rewrite it using symbols, which we already know how to do. We're going to write the negation using symbols. Then we're going to write the negation in an English sentence, okay? So, and this is very much like a question I might ask you guys on an examination, okay? Not a difficult question, but something I might ask. Okay. Our first statement, okay? All birds can fly, okay? Doesn't matter if it's true or not. I want to rewrite this using symbols, okay? So, how would I write that statement using a universal statement symbolically? Anybody want to take a guess? So, Art, go ahead, sir.
For all x, there exists bird, bird, right?
Okay, so for all x in
Domain.
domain, what domain?
Bird.
In birds, okay, so for all x in birds, good.
Okay. Then birds can fly.
And instead of birds, use what?
X.
X can fly. Very good, okay. So for all x in birds, x can fly. Okay. So that's the first part. Okay, that's not difficult. Now, I want to write the negation of this. Okay. So, it might be good for us to go back to what the negation is and just write it in the form. Okay. So, if I was to ask you guys to write the negation, you flip the quantifier. So instead of for all, there exists x in birds. Instead of the comma, you flip it to such that. And then we take the negation of the predicate. Okay? Guys, what's the negation of x can fly?
X
Cannot fly. Okay? So it's Kentucky Fried Chicken. Can't fly. So x cannot fly. Now I'm getting hungry. Nothing like greasy chicken to clog up your arteries, right? Yay. Alright. Does that make sense, guys? Flip the quantifier, comma to such that they take negation. Okay? If I wanted to write this in an English sentence, okay? Guys, what would I say to somebody if I'm talking to a 5-year-old? What's the negation of all birds can fly? There exists a bird that cannot fly. Some birds cannot fly. There is at least one bird that cannot fly. There's a multitude of different ways you could write it, okay? I like what you gentlemen said. There exists a bird that cannot fly. Is that easy enough, guys? Not meant to be difficult. It is what it is. Okay? Second sentence. There exist engineers who are good at math. Let's hope so. Okay? So, let's go ahead and write that symbolically. Okay? So, if I asked you somebody to write there exist engineers who are good at math symbolically, okay? Somebody help me out with that and tell me what that would look like, please.
There exist.
Backwards E. Okay, so we have our backwards E.
This X and engineers.
So, okay. Such that. Such that. X are good at math. Perfect.
Such that X is good enough.
Or X is good at math. Yeah. We don't lose points for correct grammar. So, X be good at math.
I'll make sure to write it like that on the.
Oh yeah, definitely. Yeah, incorporate some ebonics into that. X holds math at gunpoint, yo. Okay, that would be useful, I guess. So, whatever. Alright. Guys, that's easy enough, right, guys? Okay. If I want to write the negation of that, okay? Somebody tell me the negation, please. What would that look like?
All engineers.
So, well, not in the sentence yet. So, for all X in engineers, good. And then such that or comma. Comma, good. X is not good at math. X is not good at math. Those are the types of engineers we don't want, right guys? That's bad. Does that make sense, guys? All we're doing, we're flipping the quantifier, changing the such that to a comma. Okay? If I wanted to write the negation in an English sentence, oh, jump on, sir.
Okay, so like all birds fly, and so the upside down A, that means that's the statement. So every single bird can fly, and so the negation would be if just one bird cannot fly, then that's not true. So that's the negation.
Right. So, and we don't care if it's true or false, okay? This statement is false, right? The first one. Okay? Because not all birds can fly. But we don't care if it's true or not.
Oh yeah, I mean like it's contradicting.
Right. we know that this is true. I'm sorry, we know that this is false. I apologize. Duh. If the original statement's false, the negation must be true. Okay? So that might be what you're thinking, like, yeah, it's contradictory, so the negation must be true. Okay? Is that what you were getting at, or?
Yeah,
Okay.
I don't mean like actually true or false. I mean, the second statement just is not the first, is contradicting the first.
Right, yeah. So generally, one or the other is true, okay? If one's false, then the other one has to be true. They contradict one another, yeah. They're never both true, okay? Or they're never both false, okay? Maybe that, I think that's a better way to put it.
So like you don't have to say like, no birds can fly. You just have to say just one, at least one bird cannot fly.
Perfect,
And then-
yep, that would be exactly right to his group.
Okay.
Okay, good. All right, if I wanted to write the negation of this, just using a sentence with the engineers and the math, okay? How could I write that in just a
For
sentence?
all engineers, there exists one that is not good at math.
Okay, or even more, I guess, basic with that.
There's a
All engineers are not good.
Yeah, all engineers are bad at math, okay? I think that might be good. If you wanted to write it that way, that's
You
fine,
could say all
okay?
engineers are not good at math.
Yeah, we could
It's
say that.
probably the better way.
Yeah,
'Cause you're,
that's why I don't teach English.
'cause you're not saying all engineers are bad.
Are, okay, I see what you mean, are not good at math.
Great.
They might be okay. Yeah. Like you guys might consider somebody to be bad at math if they can't take a derivative correctly, right? Somebody else might consider that if they can't add 3 plus 3 to be bad at math. So yeah, that's true. I guess that's up to each individual. Okay. All right. Let's go ahead and do the last one.
Would it be better to say not all engineers are good at math, or is that what?
Well, that would actually be the original sentence. Not all means that there exists. Okay.
No, what you're saying up there is you're saying the first one. You're just saying there is an engineer that is good at math.
Right, and if you said not all engineers, that means there are some that are good and some that are not.
Right.
Okay, so that's still existential. Okay, all right. Other questions, guys? Okay, so let's knock out this last one. For all students, if you're a computer science major, you must take assembly program. Okay, unless you worm your way out of it because you're lucky. Okay, so let's just go ahead and write that symbolically. All right. So, for all x in some domain. Okay, guys, what domain are we looking at?
Students.
Students, right, guys? So for all x in students. Okay, and then the rest of it is literally what it says. Okay, if you are a computer science major,
If you or if X is.
we could say if x is a computer science major,
Then X must take us.
Yeah. then x must suffer. I mean, take assembly. Assembly program is horrible.
do they still teach?
I didn't mind it, but it's just so tedious. It's so low level. Yeah, it's not that bad. I mean, sometimes it's fun, sometimes it's just like, it's like mowing your lawn. I can do it whenever I wanted, it just sucks to do it. Okay, so, I don't know if it's a good analogy or not.
It's not hard, it's just tedious.
Well, sometimes it is difficult, but sometimes it's just tedious. On occasion, it's fun. So, it's like being married, I guess. Alright, I want to write the negation using symbols, okay? So, symbolically, if I was to write this, okay? So, remember, for an existential statement, for a universal conditional, we flip it. We say there exists x in students. Instead of the comma, we say such that. Well, unfortunately, it's not going to be not CS
X is a CS major
Okay,
that
so-
does not have to take.
Yes, okay, such that X is still a CS major, and, or but, X must not take assembly.
Why wouldn't you be able to replace the is a with domains?
Oh, you can if you want to, but you'd have to define that off to the side, like the predicate. So off to the side, you would have to say like d of x equals x is a CS major, and then you can replace it with c of x. Right. And unfortunately, right, that's just more writing, and we want less writing, right, if we can. Okay? That's not a note, but you're perfectly fine with that. Okay? And then if I wanted to write that in an English sentence, okay, how could you guys write that in an English sentence? Well, it's almost up there, isn't it, guys? We could just literally just read it off. There are some, there is one, there exists a student. So we would say, there exists
a CS major.
So there exists a student such that the student is a CS major and must not take assembly. I'll get there, you guys away.
Could it be there exists a student that is a CS major? Can you say that too, or is that just taking something out? Saying there's a student that is a CS major instead of splitting up into
Yeah, sure.
such that.
You could say that, and yeah, that would be fine because it's still because it's not conditional.
Right, it means the same thing.
Right, that's fine with me. There's so many different ways to write it.
So because this is an if-then statement, that first part, like the CS major, isn't affected by the not part.
Correct. The
Only the
antecedent.
Okay.
Only the conclusion is going to be affected by the negation. Okay. And let me go back just to make sure you understand why that is. If you look at the universal conditional statement, I'll check that out. Technology. That's the negation right there. So notice there exists x in the domain such that p of x and not q of
I
x.
just overread that.
No, that's okay. Or maybe underread it, whatever. So one of the two. All right. But at least you can read. So.
Yeah, that's good.
Yeah. All right. Other questions, guys, I can answer about this. Not meant to be difficult. Okay. All right. Converse, contrapositive, inverse. Okay. Stuff we already know, right, guys? Just to remind ourselves, okay, because we might have forgotten about this because that was on assignment 1. We might have forgotten what converse, inverse, contrapositive is. So let's just take a step back. Let's say we have the conditional statement, or the universal conditional statement, for all x in domain D, p of x implies q of x, okay? So that's the form of the universal conditional statement, right? What if I wanted to write the inverse of that universal conditional statement? Okay, well, it would be for all x in domain D.
Not p of x implies not q of
That's
x?
correct. Inverse is not p of x, implies not q of x. Good. If I wanted to write the converse of that for all x in domain D, does anybody remember what the converse is?
Q of x implies p of x?
Yep, you just flip them around for the converse. Very good. So it's going to be q of x implies p of x. Good. And then finally, the contrapositive for all x in domain D.
Negative q of x implies negative p of x.
Not q of x implies not p of x. Okay, let me give you guys a minute to copy that down.
Also, the quantifier does not change. The
Correct. Not for inverse, converse, contrapositive. The quantifier stays. The only time the quantifier changes is when you're taking a negation. Okay? And I want to come back to what I think John and I were discussing before, is that when you take a negation, it has the opposite truth value of the original statement. When you take an inverse or converse, it may still have the same as the original. Okay? The only ones that are logically equivalent, though, remember, are the original statement and the contrapositive. So these might be the same, these might be different. There's no guarantee whatsoever. Okay? All right. So let's just go ahead, okay, write the inverse, converse, and contrapositive of a few of these. In fact, let's just do it for letter B, because I have a feeling if we can do it for letter B, we can probably do it for letter A as well. Okay, save us a little bit of time here. Okay, so for all animals X, if X is a dog, then X has a tail and X has paws. Okay, so let's just go ahead and start with the inverse just because we can. Okay. So, and I didn't necessarily, I didn't say to write it either in symbols or in a sentence. Let's just write this one in a sentence. Okay.
Will we be asked on the exam the specific?
Yeah, I will tell you which one, and if I don't tell you which one, you do whatever you want there. Okay. So yeah, because I have to specify obviously. Okay. So the inverse would be for all. We have animals. Okay. So the inverse just takes the negation of each of these. Okay. So the negation is
If X is not a dog, then
if the animal is not a dog. Okay. So if the animal is not a dog, good.
Right, just, oh, you're not using X when you're writing it.
Right. If I'm writing,
X there.
yeah. If I'm writing something in a sentence, I like to get rid of. But since I didn't specify, you can use the X if you want to. Okay. I didn't say which way to write it. If I were saying an English sentence, no symbols whatsoever, please. All right. So if the animal is not a dog, and then what's the negation of this
then the
last one?
animal does not have tail or has paws.
Okay. And how come it's or and not and?
Because flip, negative flip.
And what law says
De
that?
Morgan.
De Morgan's law, right guys? Remember, if you take the negation of a compound statement or compound predicate at this point, you have to make sure that you change the and to an or. Okay, otherwise it's not logically correct. Okay, so you would say then the animal does not have a tail. Or the animal does not have balls. That's a sad doggy. No tail, no paws.
The fish.
It's not
Fish
a
has
dog.
tail, right?
Bird dog.
It says if it's not a dog.
Oh, good. So it's okay. So it could be like a sloth or something like that that doesn't have tails or paws. That's okay. So maybe it's a human. Converse. Okay. The converse just flips the two statement, the antecedent and the predicate around. Okay. So we would say, for all animals, if the animal does not have a tail, or I'm sorry, if the animal has a tail, and the animal has paws. So remember, with converse, we don't negate anything. Then it is a dog. The animal is a dog. It is a dog. That makes me feel a little better. And then finally, for contrapositive, we would flip them around and then take the negation of this. Okay, let me write it on the other board because I don't want to write it down here. So we would say, for all animals, and this is contra, sorry. So for all animals, if the animal does not have, I need to pick shorter sentences, don't I? If the animal does not have a tail, and maybe less morbid sentences. Tail, or the animal does not have paws, then the animal is not a dog. Okay. Mercifully. Sorry. Okay. Let me give you guys a minute to scratch that down. Okay, not meant to be difficult, right guys? We all know how to do this.
Can you use also the word not, because not goes with nor, right? Isn't it grammatically or?
One more time.
Like instead of or, can you use nor, like grammatically
No,
not?
not means and not.
Okay.
So yeah, unfortunately we can't use that.
Nor, okay.
Okay. So yeah, not's more of like an and statement. Okay, it's negation. All right. Other questions, guys, I can answer about this. Okay, pretty easy, right, guys? Okay. The last thing I want to look at this afternoon is I want to look at multiple quantifiers. Okay. So a multiple quantifier is basically going to be any statement that contains both the for all and there exists. Okay. So these are the two possible forms of one of these multiple quantifiers. Okay. So for all x in domain D, there exists y in domain E. Okay, so D is a domain and E is a domain. Okay, P of xy is going to be a predicate that has two parts. Okay, let me give you guys an example of a predicate that has two parts to it. Okay, and you don't have to copy this down, just to give you guys an idea. P of x comma y equals x greater than y. Okay, that would be a predicate that has two different variables associated with it, okay? And depending upon the values of x and y, that predicate could be true, that predicate could be false. Okay? For those of you guys that have taken Calc 3, this is just a three-dimensional function, right guys? So that's either like a sphere, okay, or it's an elliptic paraboloid, or it's a hyperboloid, whatever it is, okay? We don't care about those in this class, okay? They're fun, and they're pretty, but we don't care about them, okay? So that's what P of xy is, okay? And then the other possible multiple quantifier, there exists x in domain D such that for all y in domain E, P of xy as well. Okay, so, and what I put up here was I put the original statement, and then I want you to take a look at the negation. The negation, to be able to do this, you flip the quantifier, you replace a comma with such that, you flip the quantifier again, and you just take the negation of the predicate. Okay? So basically, guys, these all follow almost the same format if you want to take a negation, okay? Flip the quantifier, commas go to such that, or such that goes to comma, and then you take the negation of the predicate. Okay, I think they're pretty easy to remember because they all follow the same format. Okay, so let's just go ahead, let's take a few of these different multiple quantifiers, and let's try to write them in a sentence if we can, okay? This should be fairly easy, okay? So we have backwards E, x, and r, such that upside down A for y and r, x plus y is 0. Okay.
Can we write it just like that?
Unfortunately, because it says to write in a sentence, no. Okay. So let's go ahead and do this. Okay. So if I was to write the first part, like right before such that, how would you guys explain that to like maybe a 7 or 8-year-old? There exists a variable x, right? In what domain? In domain R, which is real numbers, right? Very nice. Okay, so there exists some real number or a real number, okay, such that such that what? What's this other part, guys? For all
Y.
So for all
Y in the domain, for all Y in the real number.
Such that for all
real number.
All different real numbers, okay, so for all other real numbers as well. Because remember, x and y are two different variables, so that such that for all other real numbers, right, to differentiate between x and y, okay? Because otherwise you might not know that you're using a different real number. Okay. And then, how could you guys just say x plus y equals 0 in English? Their sum is 0. Very good. The sum of the two numbers is 0. I like that a lot. Nice. The sum of the numbers is 0. Okay. Nice and easy, right, guys? That's not the only way you could write it. Okay, there's a multitude of ways that you guys could write this, and I don't have any problem with it. Okay, as long as you're not using symbols and you keep the intent of the original statement. Okay?
Remember again why we say for all other real numbers,
Oh, because-
for situations when we're using different.
Yeah, because we have two different variables. So you just want to make sure that somebody that's looking at that doesn't say that they're using the same real number. Okay?
So wouldn't it mean, because that to me is saying that you have one real number, but every other real number but it added to it.
Yeah,
is zero.
that's sort of what
So
I'm
that,
saying.
wouldn't it,
Such
wouldn't
for
it be
all-
such that there is another real number,
Okay. So we can say such that.
another real number,
We could just say instead of for all other numbers, for another real number. Okay, that's fine. Okay, it's just the intent. I think the way that you're putting it is a little more specific, and it doesn't negate the fact that you could reuse the same number. Okay, which is fine with me. Okay. All right. Other questions, guys, or comments? Okay. For the second one, for all x and z exists y and z, such that x over y is not in z. Okay. So if I was to, I guess, alliterate this or to write this out, what's the first part of that, guys?
For all integers.
So for all integers, right?
Mhm.
So for all integers, good, comma. There exists another integer. Okay, I think that's a good way of putting it. Okay, there exists another integer. Such that
The division is not zero. When they are divided, they don't count to an integer.
their quotient does not yield an integer, maybe,
Okay.
or something like that. Okay,
Okay.
Well, if you wrote that, that's perfectly fine. Okay, such that the quotient of the two numbers does not yield an integer. Okay, such that their quotient does not yield, render, produce, gimme an integer. Okay. Nice and easy, right, guys? Not difficult.
How do you specify what's being divided by what?
Generally, when you read this, like, you'd assume the first, like, it just goes from left to right, okay? But you could just say the first divided by the second, okay?
But like, is it okay to just assume?
Oh yeah, I'd be lax with that, yeah.
Okay.
And I mean, most people that would read this, especially mathematicians, they work in the order of operations, they'd assume that you were going from left to right, okay? I can't really imagine anyone going the other way. In fact, it would be more difficult for me to imagine. Okay, that's fine, and I get what you're saying, like, you just want to make sure you're writing it correctly, okay? All right, other questions, guys? Good stuff. Oh, go ahead, Dan.
Not about this, but what were you talking about when I walked in? Something about a different day or something?
No, I see, the assignment 3.
Oh,
I think we were talking about, I might make assignment 3 due after the examination, so that way you guys don't feel rushed to do that, so I'm leaning more towards doing that than the other. Okay, that's all we're doing. All right, other questions, guys, I can answer? Okay, so let's go ahead and try to do the opposite, okay? Let's try to write these as multiple quantifiers. Okay, so every real number has an opposite, okay? So, and remember, we want to write these with multiple quantifiers, okay? So that might be not so much fun, okay? So, does anybody think they might know, like, since it starts with every, okay, what do you guys suspect we would start the statement with? Yeah, for all x in real numbers, right? So I think that that's a good way to start it. So for all x in real numbers, comma, there exists a y in the real numbers r, good. Such that what? Then there's a number of different ways to write it.
Inverse.
Not inverse, okay? It's opposite. Inverse is different than opposite. Inverse is usually the reciprocal.
Okay.
You have to be careful.
such that y is the opposite of x.
Y equals negative x? Yeah, sure. I like that. So y equals negative x. Okay? I think that's a really good way to write it. In fact, that's the way I was thinking of it. Not that my way is the best way, but it's just one way.
Would it have been wrong if you put x equal negative y.
Sure, that's fine with me, because if you solved it either way, right? So it doesn't matter, they're both mathematically equivalent.
When you do something like this, you want to be able to put the two variables x and y.
Correct, because that's this right here. This is your p of x comma y, right?
Got it.
Remember, when you have a multiple quantifier, that means you have to have a predicate that has two variables in it. Okay? Good question. Or good comment. You didn't ask me anything, but you just told me. And you told me something right. That's good. Okay. Some dogs do not like treats. Why do we keep doing bad things that dogs do? Poor dog. All right. We would certainly use the backward e. So there exists x in dogs. Okay. Such that for all y in what domain, guys?
Dog.
Treats,
Treat.
right? Okay, so definitely a weird one, but so there exists x in dogs such that for all y in treats, how do we finish it off? We can't use an equal or a greater than or anything.
X does not like y.
Yeah, x does not like y. Okay, that's all we can do with that. Okay, so we would say x does not like y. Okay. So if it's a mathematical statement, we're probably more inclined to write it out. Okay, if it's just one of these types, then we're sticking with it. Okay. Okay. One more time.
It's a good thing you don't care.
Oh yeah, definitely not. I feel bad. My dog loves treats. I would never do that.
Every dog
likes
treats. There's a treat for every dog.
That's true. Every dog likes different treats, but not all treats. Okay. Guys, any questions I can answer about these multiple quantifiers? We're going to finish up the last part with multiple quantifiers next time. Then we're going to take a look at universal modus ponens and tollens. So I think that'll take us like maybe about 35, 40 minutes at most. Then we'll spend the rest of the time reviewing for the examination. Okay? So over the weekend, guys, try to work on assignment number 3. You can pretty much do almost all of it except for maybe the last 4 questions or so. And then if you guys have questions for me on Monday, we can answer.
Now, are you going to be bringing out the solution for the exam 1? Not solution, sorry. The one that you posted, the review?
I'm going to try to, okay? So it depends on how busy I am this weekend.
Okay.
It's usually busy, but-
What are the rules?